Hi, this is a presentation of VLANs in my advanced networking course. So today I'm going to tell you about the basic things about VLANs. VLANs, it's something that we do on layer 2, and we do it to divide our network into smaller parts and thereby reducing the broadcast traffic. That's the main idea why we are doing it. We want to reduce the amount of broadcasts. And when we divide our network into VLANs, we separate the broadcast traffic as well so that it will be separated into each VLANs. So what we actually do is that we divide it into smaller parts or smaller segments, and we do that within a layer 2 device, which is a switch. So we set up the switch to work with different VLANs. If we want to communicate between the different VLANs, you have to route the traffic between them. The hosts, the PCs, the other devices that you connect to a VLAN is actually not aware of that the VLAN exists. So here, for instance, we can divide our network here into, in this case, 3 different VLANs. We have VLAN 2, which is IT, VLAN 3, which is HR, and VLAN 4, which is sales. These computers will be completely separated from each other when they are connected to different VLANs. If I want some kind of communication between these VLANs, I put in the router down here, and then we can route the traffic between the VLANs. But if I send out a broadcast here on VLAN 2, the broadcast will only be seen by the computers that are connected to VLAN 2. So we have actually like a switch here and a switch here and a switch here, but really we have 3 different switches that are connected to all these 3 VLANs. Yeah, so the benefits. Well, of course, we have the better performance, which I think is the most important one, but also the security, because since the computers on different VLANs cannot see each other, they are, of course, not able to do something that they are not supposed to do either. So we get the security and benefits as well. The cost reduction means that instead of, for instance, if I wanted to segment my network, I could buy a switch for each segment. But in this case, when we're using VLANs, I can have one switch where I have 4 different VLANs. So instead of buying 4 switches, I can have one containing 4 different VLANs, for instance. The whole idea with the performance is, of course, also that my broadcast domains are smaller. And also, I think it's for IT professionals, it will also give you a better overview of your network because you will put them into more manageable sizes. So you have your IT VLAN, your HR VLAN, or here at my school we have a student VLAN and an admin VLAN and a teacher's VLAN, for instance. So it gives you a better structure of your network. Yeah, when we look at the types of VLANs that we can have the normal data traffic. It's a data VLAN. We have something called the default VLAN. On Cisco switches, all ports belong to the default VLAN, and the default VLAN is VLAN 1. So if you don't do anything with your switch, you still have a VLAN, and that is VLAN 1. Then we have something called the native VLAN. The native VLAN is actually where you have package that doesn't belong to any VLAN and doesn't have this little tag on the traffic that says that this is belonging to a specific VLAN. And then we have the management VLAN, the one that you can configure and set up if you want to configure your switch over the network, for instance. That is the management VLAN. When you want to get an overview of your VLAN, you can use the command show VLAN brief, and you will get an overview. In this case here, we can see that we have only the default VLAN 1, and all ports belong to this VLAN. You can also see that we have an FDDI and a token ring, 4 different types of networks that are already there. This is something that in all Cisco switches are pre-configured, and you cannot really do anything about that. We can also see that all ports belong by default to VLAN 1. The native VLAN is VLAN 1. Management VLAN is VLAN 1. And VLAN 1 cannot be renamed or deleted, so it's always there. The voice VLAN is something that you use for your IP or voice over IP traffic. This is something that you need to take special care of because the voice traffic is something where you need to ensure the voice quality, which means that you need to set up some kind of quality of service to be able to use voice over IP. But you can put in a voice VLAN and thereby set all these things that need to be done on voice over IP traffic on this specific VLAN. So normally within a IP phone you will actually find a small switch. So because normally on a switch port, the switch port can only belong to one VLAN at a time, but not if you have a voice VLAN, because here this voice or IP phone is connected to a switch, and this switch will actually see two VLANs. It will see the voice VLAN and the data VLAN, and the switching from the data traffic to the voice traffic will happen within the IP phone, because this is actually a small switch. So we can see here in port 1 where the traffic comes in, port 2 is the voice VLAN, and port 3 is the data VLAN. VLAN trunks is something that we use when we want to carry traffic from more than one VLAN. For instance, when we want to have the same VLAN to be configured on more than one switch, we want the traffic to go from one switch to another. Of course, if we have 10 different VLANs, we should actually have 10 different connections between the switches, and we don't want that. So instead, we will put in or trunk the lines between the switches so that it can carry traffic from all the VLANs. And we are actually using a protocol called 802.1q to trunk the traffic. So here you can see that switch 1, 2, and 3, well, they all have these 3 different VLANs, VLAN 30, 20, and 10. And to be able to communicate within all the 3 switches here, well, we just trunk the lines between the switches, and thereby the traffic can be sent on all different of these switches. We also have a management and a native VLAN configured here. Yeah, so the broadcast domains are controlled within the VLAN because they will only see the switch will create their own layer 2 segment where you will be able to limit the broadcast within the segment. So the broadcasts are only sent within the VLAN. And if you want to communicate between the VLANs, you need to put in a router, and the router will always also limit the broadcast to the different VLANs. Yeah, so what we actually do is that we tag the frames, the Ethernet frames, for VLAN identification, especially when we are using trunking. We need to somehow make sure that, because then we send them all through the same cable, and we want to make sure which VLAN belongs to where. So in this case, we just put on a small tag, and this is where we identify the VLAN. This is done, for instance, in the IEEE 802.1q, which is the protocol that we use for tagging. So what we actually do is that we insert this small tag within our Ethernet frame after the source MAC address and before the type length field. And this tag will then identify our VLAN. There are some types of traffic that don't really like the tagging part, and this is where we have the native VLAN. A frame that has no tag will belong to the native VLAN. And a frame that is received untagged will remain untagged. And if no ports are assigned to the VLAN, the native VLAN, then they will be dropped. And in Cisco switches, VLAN 1 is by default the native VLAN. We can also see here that when we are tagging or the IP phone, the Cisco IP phone will also see that there are different VLANs, and it will be configured to tag voice traffic, for instance, in VLAN 150, and configured to send untagged traffic on the data VLAN over here, for instance, VLAN 20. So the built-in switch here will see the different VLANs and also see whether they are tagged or not. Yeah, so how many VLANs can we have? Well, we have two different categories of VLANs. We have a normal range VLAN, which goes from VLAN 1 to VLAN 1005. These are stored in the VLAN dat file in the flash. And we have something called VTP that can learn these VLANs. If we need more, we have an extended range also going from 10,000 or 1006 to 4096. And this is all stored in our NVRAM. And if we use VTP, we cannot use, they will not see the extended range. Yeah, so a VLAN is something that we use to take our switch over here. This is a switch. Whoops. And we have a lot of ports in it here. Yeah. So what I do when I create a VLAN is that I take, for instance, these here and say that this is VLAN 20. And over here we have VLAN 30. And what I actually do is that I take and cut my switch into smaller parts. They will not be able to see each other, these VLANs. So if I put something in here, they will not be able to see what's put in on VLAN 30, for instance. So I actually take some kind of a device and divide my switch into many different segments or smaller parts. Yeah, that was it.